Hi, it's Brian here at Acoma Optical, the oldest optical laboratory in the state of New Mexico, and the only optical laboratory in the state of New Mexico that produces digital lenses. Come on in, let me show you how we make some lenses. After you've selected a pair of eyeglasses from one of our opticians here at Acoma Optical, our first step is taking a tracing or a very accurate measurement of your frame. This measurement is done on a special three-dimensional tracer that comes out and takes a measurement of each eye. The computer picks up 800 different data points on each eye, making it one of the most accurate forming devices in the state of New Mexico. Once this process is complete, we send it over to a main computer or a server that stores all of this data that we'll use for this particular eyeglass frames. Even though we carry very accurate and quality frames, we still find that there is some irregularities in the manufacturing process. So on the screen is an accurate representation of what the lenses will look like and how we're going to cut the lenses down into this frame. And you can see on the screen that we're accurate to 1/10 of a millimeter. After we've done the calculations on the lenses, we then proceed to a station where we cover up the front surface of the lens. It's what we call a semi-finished lens. Since we don't manipulate the front surface of the lens, we're going to protect it with this particular surface saver. The surface saver not only protects the front surface, but it's a good dispersion of heat. After we've covered up the front surface of that lens, we take a cooled or a chilled ring and we set it up on a blocking station. This blocking station has a protractor on it that gives us the angle and direction that allows us to block this lens. We look down through the eyepiece to center up the lens. We hold on to the lens and then we inject a low melting point alloy into the lens. Once this alloy is cooled off, we're going to remove the dormer, and now we have a way to hold on to this lens. And it's very rigid, so we can very accurately machine this pliable material. This is a one-of-a-kind three-dimensional lens lathe. It's the most accurate in the state of New Mexico. It's made by Satis Low. And once we've done all the calculations on our server, then we take that data point file and we bring it up into this three-dimensional lathe. This is a very highly accurate lathe because it's run by pneumatics or air. So it's constantly being recalibrated so that we have a stable platform to make these highly precise lenses. This is how we create the freeform or the progressive lenses. After the lens is chucked up inside of this three-dimensional lathe, the first step is it starts turning and water is injected to the tips and it reduces the heat. The lens slides all the way to the back to the large round wheel and it cribs it down very quickly. This cribbing process sizes the lens down to the amount that we need to process or to be able to place the lens inside the person's eyeglasses. After it's done sizing or cribbing the lens down, it moves up to Fast Tool 1. Fast Tool 1 hogs down the lens. It's a very fast way of taking off materials and it's a rough cutting process. Once we're done with this rough cutting process, we go to Fast Tool 2, which is a very fine process that creates a very complex surface on the lens. The whole time the lens is rotating and the cutters are actually moving in and out to contour or create the curves on the surface of the lens. After we've removed it from the three-dimensional lens lathe, we have to have a way to polish these highly complex curves on the back side of the lens. We take the pads and we put them up onto the top of the heads. Now that we've had the lens on the bottom and the polishing head on the top, these start to rotate inside of the machine and the polishing head comes down from the top. We inject polish into the lens and it polishes this highly complex curves back out to optical clarity. Now that we've finished scratch resistant coating the lens, we bring it over to the finish side of the laboratory. First step in our finish side is to check the lens for accuracy. We do that on our digital lensometers that are accurate to 1/100th of a diopter. Once we have accurately measured the lens, then we place a spot where optical center of the lens is to place it right over the patient's pupil. Now that we have checked the lens and placed the optical center, we need to hold on to this lens so we can cut it to the shape of the frame. we're going to decenter the optical center so it fits over the pupil inside of the frame. And it's a way of us being able to hold the lens so we can manipulate it or cut it down to the shape of the frame. And we do this on a finished blocker. After we have checked the lens for accuracy and marked the optical center on them, we're bringing it over here to the finished blocker. We've called up the job from our server and it's memorized or kept the shape on file. I'm going to take the lens. We will chuck it up inside using pneumatic press. The lens will move over and a high-speed tungsten carbide cutter will spin up and cut the lens very accurately and very quickly. First step it's going to do is come across and check where the curves are or where that lens is in space. It's going to measure the front surface since it's an angled curve, and then the next probe is going to come out and touch the back surface. Once it has all the calculations, it's going to cut down that lens to the customer's frame. Now we have a precisely cut lens that fits into the customer's frame. After we've pulled it off of the edger and made sure that the size is accurate to the frame, we'll now need to make sure that the edges are not sharp. And we do that by placing it on an industrial diamond bonded wheel. We put a little water on, and we place the lens onto that wheel at a specific angle.